The name of topic is varactor diode, gun diode, and laser diode of the analog electronics subject. So we first of all discuss about the varactor diode. And what is the varactor diode? Varactor diode is a special type of PN junction diode. So in which PN junction capacitance is controlled using reverse bias voltage. So here the reverse bias voltage is controlled by the capacitance. When the diode is forward bias, current will flow through the diode. That is the own condition of the PN junction or this diode. When the diode is reverse bias, charge in the P and N semiconductors are drawn away from the PN junction. So interface and hence form the high resistance depletion zone. So if the PN junction of the semiconductor diode is reverse biased, so there is a formation of depletion region. In depletion region or depletion zone, there is no flow of charge carriers or the charge carriers in immobile condition, or there is a no flow of charge carriers across the junction. So other names of the varactor diode, which is also known as varactor variable capacitance diode. Second one is voltage variable capacitor diode. And third one is also known as tuning diode and also known as variable reactance diode. So these are the others name of the varactor diode. This is the schematic symbol of the varactor diode. It have the two terminal. One is the anode and second one is the cathode. So it is the two terminal device. Anode is the positive terminal and cathode is the negative terminal. What is the basic operation of the varactor diode? So operates in reverse bias and this gives rise in three regions. At either end of the diode are the P and N regions. So in the uh, varactor diode, there is two regions, P region and N regions. However, around the junction is the depletion region where no current carriers are available. So we know that in the depletion region or uh, there is no charge carriers are available in depletion region. So as a result, current can be carried in the P and N regions, but the depletion region is an insulator because there is a no flow of charge carriers. So depletion region behave as a insulator. Same as capacitor construction, it has conductive plates separately by an insulating dielectrics. So this is the capacitor construction. The capacitance of a capacitor is dependent on a number of factors, include the plate area, the dielectric constant of the insulator between the plates, and the distance between the two plates. So the capacitance of the capacitor depend on these parameters. In the case of varactor diode, it is possible to increase and decrease the width of the depletion region by changing the level of reverse bias. And we can also know that the depletion region width is changed by the changing in the reverse bias across the EN junction. So this has the effect of changing the distance between the plates of the capacitor. So it has also the effect of the changing the distance between the plates of the capacitor. And we see here in this two diagram of varactor diodes. In diagram A, we applied the reverse biasing voltage to 3 volt, and in that case, this is the reverse bias varactor diode. So the here a value of capacitor will be 20 picofarad. What we draw the second diagram in which we applied the external reverse voltage 6 voltage, then the value of the capacitor across the depletion region will be 5 picofarad. So we can say that the width of the depletion region is depend on the applied external reverse voltage across the PN device. So depletion region change or width of depletion region change with applied the reverse voltage. So also change the capacitance across the depletion region in this varactor diode. This graph shows the characteristics of the varactor diode. The graph between the capacitance versus reverse voltage. So this shows the varactor voltage capacitance characteristics, and in this graph there is change in capacitance, also the change in reverse voltage. If we change the reverse voltage, so the value of capacitance also change with the reverse voltage. So this is the characteristics of varactor voltage capacitance characteristics of the varactor diode. Basically, the construction of varactor diode, which materials are used in this varactor diode construction. So varactor diode are manufactured with gallium arsenide GaAs, has a higher operating frequency or up to nearly 1000 gigahertz. This is the very high frequency. So this varactor diode are generally designed for this higher operating frequency. In this construction of varactor diode, we see here there is a gold plated molybdenum stud, and below this there is gold plated wire ceramic tubes, and there is also a diffuse mesa gallium arsenide. So also is bottom part a gold plated molybdenum stud is also there. So this is the construction of the varactor diode. Now we discuss about the VI characteristics or current versus voltage graph of the varactor diode. We see in this graph, we take the forward current in the milliampere range and reverse current in the microamperes, and voltage, forward voltage in voltage, positive voltage, and reverse voltage take the in negative voltage. So here are two characteristics are shown in this graph. One is the forward bias and second one is the reverse bias. In forward bias, there is a knee voltage, which is the zero point 0.3 volt for germanium semiconductors and zero point 0.7 volt for silicon semiconductor. So after this knee voltage, the diode is conduct and the voltage increase, so the current also increase with respect to voltage. So this show the forward bias of the varactor diode. What in reverse bias graph we see here, if we increase the reverse voltage but there is no increase of reverse current, or we increase the reverse voltage but the current is remains constant, but at a reverse breakdown voltage the reverse current is suddenly increased, rapidly increased. So this is the phenomena is called the Zener breakdown or avalanche breakdown. So if this voltage, this phenomena occur, that voltage is the reverse breakdown voltage, and the current flow in that case, this is the reverse bias current or breakdown current. Basically, this is the range of the 50 microampere for germanium and 20 microampere for the silicon. So this is the reverse current. There are many applications of the varactor diode. So first is variable reactor in microwave circuit, and second application it is used in variable resonant tank LC circuit. Here C part is very using varactor diode. C is the capacitor, and AFC automatic frequency control, where in varactor diode is used to set LO signals. So varactor diode is used as a frequency modulator in radio and television sets. So this is the fourth application of the varactor diode, which is used as a frequency modulator in the radio and television systems. And next, it is used as a frequency multiplier in microwave receivers. And also it is used as a RF phase shifter. So these are the some applications of the varactor diodes and different fields. Now we conclude that the varactor diode in reverse bias operate as a variable capacitor as reverse voltage vary where. So reverse voltage change, so capacitor also change with the reverse voltage, and depletion region or behave as a insulator or dielectric when device in the case of reverse bias, and PN region plates of capacitor, and width of depletion region, distance of separation, which is depend on the applied the reverse voltage across the varactor diode. So there are, that is the conclusion of varactor diodes. Now we discuss about the next gun diode. So the gun diode is considered as a type of diode, even though it does not contains any typical PN diode junction like the other diode. So in gun diode there is a no PN junction diode like the other diodes. What it consists of two electrodes. It have the two electrodes. This diode is also called as a transfer electron device or TED device. This diode is a negative differential resistance device which have the negative resistance and which is frequently used as a low power oscillator to generate microwave. And this diode or gun diode basically used as a low power oscillator for generate the uh, microwaves. So this is the application of a gun diode. It consists of only n-type semiconductor in which electrons are the majority charge carriers. And we know that in n-type semiconductor, there are number of electrons are more as compared to number of holes. So the electrons are majority charge carriers in n-type semiconductors. So to generate short radio waves such as microwaves, it utilizes the gun effect because this diode or gun diode have the gun effect. A photo of the gun diode. A gun diode is also known as transfer electron device, TED device, is a form of diode at two-terminal passive semiconductor electronic equipment component with negative resistance used in high frequency electrons. So this is the property of the gun diode, which use the negative resistance and high frequency used for high frequency and have the two terminal passive semiconductors. Next, what is the gun effect? So it was invented by the Jones Wattis Combil gun in 1960 after his experiments on gallium arsenide. He observed a noise in the experiments results and this too generate of electrical oscillations at microwave frequency by steady electric field with a magnitude greater than the threshold voltage. It was named as a gun effect after this had been discovered by a gun, JB gun, and the gun effects can be defined as a generation of microwave power, power with microwave frequency of around a few gigahertz. So this is the very high frequency of the microwave. Whenever the voltage applied to a semiconductor device, so exceed the critical voltage value or threshold voltage value, in gun diode oscillators, gun diodes are used to build oscillators for generating microwave with frequency range from 10 gigahertz to terahertz. It is negative differential resistance device, also called as transfer electron device, TED device, oscillators, which is tuned circuit consisting of gun diode with DC bias voltage applied to it, and this is termed as biasing the diode into negative resistance region. Due to this, the total differential resistance of the circuit become zero as the negative resistance of the diode cancel with the positive resistance of the circuit. resulting in the generation of oscillations. What is the working principle of the Gunn diode? So this diode is made of single piece of N-type semiconductor such as gallium arsenide and INP, indium phosphide. Gallium arsenide, some other semiconductors materials have one extra energy band in their electronic band structure instead of having only two energy bands with valence band and conduction band like normal semiconductor materials or normal semiconductors and other semiconductors like germanium. Also, these gallium arsenide and some other semiconductor materials consist of three energy band, and this extra third band is empty at initially state. So two band is the one is the conduction band and second is the valence band, and third band extra band is the empty in initial stage in this gallium arsenide semiconductor. So if a voltage is applied to this device, then most of the applied voltage appears across the active region. The electrons from the conduction band having negligible electrical resistivity are transferred into the third band because these electrons are scattered by the applied voltage. The third band of gallium arsenide has a mobility which is less than that of conduction band. Because of this, an increase in the forward voltage increase the field strength or the field strength where applied voltage is greater than the threshold voltage. So if we applied forward voltage, so we increase the forward voltage. If the strength of the forward voltage is greater than the threshold voltage value, in that case, then the number of electrons reaching the state at which the effective mass increase by decreasing their velocity, and thus the current will also decrease in that case. Thus, if the field strength is increased, then the drift velocity will decrease or flow of drift of charge carriers decrease. This creates a negative incremental resistance region in BI characteristics or BI relationship. Thus, increase in the voltage will increase the resistance by creating a slice at the cathode and reach the anode. What to maintain the constant voltage? A new slice is created at the cathode. Similar, if the voltage decrease, then the resistance will also decrease by extinguishing any existing slice. There are Gunn diode characteristics. This graph shows the graph between current versus voltage. So in this graph, we see initially stage when we increase the voltage, so current also increase and increase up to maximum peak value, that is the peak point, that current will be IP and at the peak voltage BP, and after this peak point the current is decreased in typical operating point. So this is the negative resistance region, because in this region we increasing the voltage where current is decreasing. So this show the negative resistance region of the gun diode characteristics. At the point where point is the belly point, after this point voltage increase, so also current increase with the voltage, and the current increase at the maximum operating limit. So this graph show the characteristics of the gun diode current versus voltage relationship. The current voltage relationship characteristics of a gun diode are shown in the above graph with its negative resistance region. These characteristics are similar to the characteristics of the tunnel diode. As shown in the above graph, initially the current start increasing in this diode, but after reaching a certain voltage, that is the peak voltage level at a specified voltage value called as threshold voltage value, the current decrease before increasing again. The region where the current falls is termed as a negative resistance region, and due to this it oscillates in this negative resistance region. This diode acts as both oscillator and amplifier. So this diode behave as a oscillator, also as a amplifier. As in this region, the diode is unable to amplify signal, or in the case diode have the uh, uh, unable to amplify the signal or increase the strength of the signal. In that case, what is the application of the gun diode? So there are some applications of gun diodes. Gun diode used as a oscillator to generate frequency ranging from 100 milliwatt 5 gigahertz to 1 watt 35 gigahertz output. These gun oscillators are used to radio communications, military and commercial radar sources. Used as sensor for detecting trespassers to avoid derailment of trains. Used as efficient microwave generators with a frequency range of up to hundreds of gigahertz. Also used for remote vibration detectors and rotational speed measuring tachometers. Also gun diode used in measuring the tachometers, and used as a microwave current generators, pulse gun diode generators, that is the pulse gun diode generators which used as a microwave current generator, and also gun diode used in microwave transmitters to generate microwave radio waves at very low powers, and used as fast controlling components in microelectronics, such as for the modulation of semiconductor injection lasers. And also gun diode used as sub-millimeters wave applications by multiplying gun oscillator frequency with diode frequency. So these are the some applications of gun diode. Now we now discuss about the next type diode is the laser diode. What is the laser diode? So laser stand for the light amplification by stimulated emission of radiation. So this is the full form of the laser, or laser stand for the light amplification by stimulated emission of radiation. A laser diode is an electronic device which convert electrical energy into light energy. So laser diode convert the electrical energy into light energy to produce high intensity coherent light, and also this produce the high intensity coherent light. And laser diode is very small in size and appearance, so it is similar to transistor and has operation like LED, but it emits coherent light. It is similar to the transistor and also as a light emitting diode operation, but it has emit the coherent lights. This is the main difference between laser diode and simple LED and transistors. So material which often used in laser diode is the gallium arsenide, GaAs. This is the compound semiconductor material. It is also called injection laser diode. This is also, we can also uh, say that is the injection laser diode. It work on forward bias condition, and work of this diode depend on the biasing, and this laser diode work in forward biasing. When external biasing applied to this laser diode in the manner of forward biasing, so this is the conduct in that manner. That is the symbol of the laser diode, which have the two terminal. One is the anode and second one is the cathode. Anode is the positive terminal and cathode is the negative terminal. And here the arrow show the emit of the coherent light in the laser diode. So this is the symbol of the laser diode. What is the laser diode construction? So in construction, the laser diode is made of two doped gallium arsenide layers. One doped gallium arsenide layer will produce an N-type semiconductor, and whereas another doped gallium arsenide layer will produce P-type semiconductor. So this is the P-type semiconductor diode. And in laser diode, selenium, aluminum, and silicon are used as a doping agent. So some we do the doping in this laser diode of the selenium, aluminum, and silicon here. So we in this diagram there is the p-type semiconductor and n-type semiconductor. They are joined to each other, and after joined the here a form a junction between the p-type semiconductor and n-type semiconductor, and a depletion layer also generate across the junction. There is some immobile charge that is the we have as a insulator across the junction or depletion layer we have as a dielectric or insulator. So the width of the depletion layer depend on the applied reverse voltage across the this PN semiconductor. So when a p-type layer is joined with a n-type layer, so a p-n junction is formed. The point at which the p-type and n-type layer are joined is called p-n junctions. So there is the formation of p-n junction between the p-type semiconductor and n-type semiconductor. The p-n junction separate the p-type and n-type semiconductors. So this is the construction of laser diode. But main step required for producing coherent beam of light in laser diode. So this is the main steps to producing a coherent beam of light in laser diode. So absorption of energy is the process of absorbing energy from the external energy source. In laser diode, electrical energy or DC voltage is used an external energy source as a biasing voltage. When the DC voltage or electrical energy supply enough energy to the valence electron or valence band electrons, they break bonding with the parent atom and jump into the higher energy level or conduction band, or jump from the valence band to the conduction band or higher energy level. So the electrons in the conduction band are known as the free electron. So these electrons jump from the uh, valence band to conduction band. So these electrons called the free electrons. When the valence electrons leave the valence cells, so there are basically two bands, valence band and conduction band. So valence electrons, which is in the valence band, leave the valence cell, and empty space is created at the point from which electron left. So this empty space is the valence cell is called a hole. So this is called as a hole. Thus, both free electrons and holes are generated as a pair because of the absorption of energy from the external DC source. So we can see in this diagram there is a two level of energy, E2 energy level and E1 energy level. Here the electrical energy fall and break the covalent bond, and the valence electron uh, jump from the uh, valence band to conduction band, and free electron also in the E2 high level state, and at the holes at the E level states. So the valence electron jump into the higher energy state after absorbing the energy. So this is the process of the uh, laser diode. Or so spontaneous emission. What is the spontaneous emission which is occur in the laser diode? So spontaneous emission is the process of emitting light or photons naturally while electrons falling to the lower energy state. In laser diode, the valence band electrons or valence electrons are in the lower energy state. Therefore, the holes generated after the valence electrons level are also in the lower energy state. On the other hand, The conduction band electrons or free electrons are in the higher energy level or E2 energy level. In simple word, free electrons have more energy than holes. The free electrons in the conduction band need to lose their extra energy in order to recombine with the holes in the valence band. The free electrons in the conduction band will not stay for long period. After a short period, the free electron recombine with the lower energy holes by releasing energy in the form of photons. So this is the in this diagram show the spontaneous emission in which there are free electrons releasing photons or light energy while recombining with the holes. So this is the show the spontaneous emission in the laser diode. Next, what is the stimulated emission in the laser diode? So stimulated emission is the process by which excited electrons or free electrons are stimulated to fall into the lower energy state by releasing energy in the form of light. The stimulated emission is an artificial process. In stimulated emission, the excited electrons or free electrons need not wait for completion of their lifetime. Before the completion of their lifetime, the incident or external photons will force the free electrons to recombine with the holes. In stimulated emission, each incident photon will generate two photons. So all the photons generated due to the stimulated emission will travel in the same direction. As a result, a narrow beam of high intensity laser light is produced. So this is the uh, diagram which show the stimulated emission in which free electrons releasing two photons while recombining with the holes. So this is the representation of stimulated emission in this diagram. Now, how laser diode works? When DC voltage is applied across the laser diode, the free electrons move across the junction region from the N-type material to the P-type material. In this process, some electrons will directly interact with the valence electron and excite them to the higher energy level, whereas some other electrons will recombine with the holes in the P-type semiconductor and release energy in the form of light. This process of emission is called the spontaneous emission. The photons generated due to spontaneous emission will travel through the junction region and stimulate the excited electrons or free electrons. As a result, more photons are released. This process of light or photons emission is called stimulated emissions. The light generated due to stimulated emission will remove parallel to the junction. The two ends of the laser diode structure are optically reflective. One end is fully reflective, whereas another end is partially reflective. The fully reflective end will reflect the light completely, whereas the partially reflective end will reflect most part of the light but allow a small amount of light. The light generated due to the stimulated emission is escaped through the partially reflective end of the laser diode to produce a narrow beam laser lights. So all the photons generated due to stimulated emission will travel in the same direction. Therefore, this light will travel to long distance without spreading in the space. So this is the diagram, construction diagram of the laser diode, in which reflected photons and highly reflective ends there, and there are two terminals, one is anode, second is cathode, and there is also a depletion region and light emissions and partially reflective ends. So there are p-type or n-type semiconductor. Between the n-type and p-type semiconductor there is the formation of a junction and also the depletion region across the junction, and there are uh, the flow of charge carriers from one side to another across the junction. So this is the construction diagram of the laser diode. What is the advantage of laser diode? So there are some advantage. Simple construction, lightweight, very cheap, small size. It have highly reliable compared to other type of lasers, and longer operating life and high efficiency. Mirror are not required in the semiconductor lasers. So low power consumption device. That is the some advantage of laser diodes. And also there is some disadvantage. So not suitable for the application where high power are required. And semiconductor lasers are highly dependent on temperature. So there are some application and of laser diodes. The first is laser diode are used in laser pointers. Second one, laser diode are used in fiber optic communication and also used in barcode reader, and also used as a laser printing, laser scanning, and range finder. These are the some application of the laser diode. These are some reference books for this topic, and there are some multi-choice questions that is very interesting and important. Thank you very much.